Good day, all. Sorry for all the confusion this morning, but the weatherman seemed to think that we were going to really get a lot of rain about the time that we have class, so I wanted it to be a more of a enjoyable experience rather than we're going to get dirty from the mortar, and I didn't want to add to it with getting dirty from wet and mud and everything else. So we will continue on and move forward with our studies. So I put this big Zoom button up there for everybody to you can just hit on that and we can start the meeting. Don't have to worry about emails or anything like that. So anybody having any problems with any of the masonry stuff? Any of the questions? Anybody got any specific questions about the masonry? You've looked at all of the videos and understand everything. I also put the estimating masonry on here, parts 1 through 4, which are more or less PDFs, and you should be able to get to those. So if you want to download those, by all means, go at it. So I'm going to open up the wood, and we're going to start off with talking about trees and stuff. So before I get too far, let me see if I can hide this thing here. There. The assignment that you're going to see here, trees from your yard. Okay, so it doesn't have to be from your yard. I know some of you guys may live in an apartment where you don't have a yard, but nevertheless, what I want you to do is, walk outside, go to the park, wherever, go in the woods, to the nearest woods, wherever you want to, and I want you to take some pictures of trees, and I want you to research what they are, find their species, and what their uses are. What do we use them for? Do we use them for furniture? Do we use them for construction? And that kind of thing. Don't just take a picture, send it to me, and say, pine tree. I don't want that. No, I want you to do some research on it and tell me a little bit about it. Also, I want to know, and I'll update this description here. Also, I want you to tell me where it originates from. Is it a native tree to Western North Carolina, or is it an invasive species? We have a lot of invasive species. So try to find out where their origins are. And, when do they bloom? When do they, what kind of leaves do they have? What color do they turn in the fall? Can their bark be used? For instance, like a poplar tree, we use poplar bark to do nice, pretty finishes on the exterior of a house. So that kind of thing. Put a little bit of effort into it. It's I don't have a whole heck of a lot of assignments in this class, but this is one of them. So, make the best of it so that you're learning something. So let me, first of all, let me close some of this crap. Let's talk about the tree, not the ancestry tree. I don't know how that came up. Tree. There. Okay, so when you're looking at a tree, you're looking at half of it, basically. For every tree that you see, there is an equal amount of woody roots underneath the ground. So, not counting the leaves, but, like in this tree here, where you're looking at something like this, then there is just as much root under the ground. So you're only really seeing half of the tree there. So keep that in mind as well. And, trees, they have different characteristics. Obviously, I mean, you know, so this tree here is you know, out in the desert somewhere in Africa, so it has, you know, a very large canopy to try to shade itself from the heat. Most of the trees that we have around in the United States are, you know, they're bushy type trees. If you look up red oak, whoops, let's not. So red oaks, they generally grow up. All right, so you get a little bushy, but they're mostly going up. And the white oak is mostly going out. So you can see kind of a difference. So a white oak does not grow, most of the time does not grow in a forest. It grows out in the open because it needs that area to move around. A red oak, on the other hand, is going to grow up, and you'll see it mostly in the forest. We have more species of red oak in Western North Carolina than we do white oak. And when I say red oak, we have scarlet oaks and we have post oaks, and, you know, there's just tons of different oaks. And so, you know, I'm not going to require you guys to memorize the Latin names or anything like that. My son, he is in plant science, and he had to, you know, I mean, that was part of the thing. But in here, I would rather you know what its uses are in construction than anything. So, you know, being furniture or flooring or walls or trim, or even, you know, poplar, we can't, you know, we don't really use it for any kind of flooring, anything, but we do use it in cabinetry, not necessarily being seen per se, but, you know, in the drawers, because it is a very stable wood. It doesn't move and expand and contract. So let's start off. And we're going to talk about the tree section, and you're going to be required to label one of these. You may see something like this in a test. Actually, I'm not going to lie to you. You will see one in a test. So let me find a nice big one here. Yeah, here we go. And then I want to find. Okay, so when we're looking at this section here, there are certain properties of the tree that we must understand. And by meaning must understand, then if by understanding it, we know what works best for anything in construction. So when we start out, obviously we see the bark. And the bark is nothing more than its protection. It is its skin. It keeps, it tries to keep insects away from the inside of the tree. It tries to keep, you know, wind, cold, everything away from the inside of the tree here. And as we go in, we have a portion of the tree that is living, and a portion of the tree that is, it's still living, but for the most part, it does not have a function other than stability. So we have what is called the sap wood. And the sap wood is just what the name says. That's where all the nutrients and stuff are going to run through this tree, are in the sap ring. Inside, in this darker ring that you see here, we have the heartwood. And the heartwood acts as its bones. Heartwood. Let's try that again. Heartwood. So it acts as its bones. It's its strength. So the bigger it is, hopefully, you know, the stronger it is. And not a whole lot of activity goes on in here. And especially in a red oak or in an oak, especially white oak, you will find out that the center of this sometimes, and you'll hear them called water oaks sometimes, because the inside will start decaying. The outside of it's living fine, but the inside of it will start decaying and you get water in there. And then when you cut it down, you just have this water pouring out of the tree after you've cut it down. But so water oak is really not a species. It's more of a nickname that the locals give to it. And also when I talk about the sap, all right, so you'll hear folks say, and it's mostly old timers that will say that the sap will stop, well, not stop, but it will descend, we'll call it that, descend to the roots during winter. Well, this is a very common misunderstanding. This does not happen. The sap actually is deterrent to temperature a little bit. Now, you've heard me say that organic materials expand and contract with moisture, and mineral materials expand and contract with temperature. But sap is something that will solidify in colder temperatures. So it doesn't descend back into the roots during the winter, but it will solidify a little bit. So it will become not a complete solid, but it will definitely slow down during the winter, only because of the winter cold months. Now in Florida, nope, don't happen. It stays year round. That sap runs between the tropics and the tropical ranges. That tree's going full blast all the time. So you know, we think about the temperature as being a big deterrent as to coloring, as to changing our leaves, but it is actually sunlight. So if you know, if we have a limited amount of sunlight, say, I don't know, 4 hours a day, then that tree is, you know, it senses that it's going to be wasting its time trying to have energy to put forth to its leaves and do this photosynthesis. Photosynthesis. And so it'll shed its leaves in order to conserve energy during the winter months. So it goes into a hibernation mode. And that's the next thing I kind of want to talk about. So in this center port here, you have what is called the pith. And the pith is just like it says, it's pithy. It's kind of spongy-like almost. It doesn't have any rigidity whatsoever to it. And that's part of the reason why oak trees are susceptible to rot in that portion, because the rest of the tree is super hard. And then you've got this little pith in the inside of it that will hold water and will cause problems later on. But so moving on, when let's say, for instance, pull this real far in there where we can see it. So you'll notice that we have a section here that is kind of white color or lighter color. And this is the spring growth. And what happens in the spring growth is somewhere about here, we get, it's about March, and my pen is not going to let me, can I go to something thinner? March, nope, I can't. If I hit that again, will it give it, yeah, I can get that smaller. Okay, so March. All right, so in March, roughly, I'm guessing, it all depends on the amount of light and temperature that we have. So generally about the middle of March, we're starting to get more sunlight. Also in March, we have the equinox, meaning that we have 6 hours, or excuse me, we have 12 hours of sunlight, 12 hours of darkness in our hemisphere above the tropic line. So between the tropic line and the Arctic line, we get 6 and 6, or damn it, we get 12 and 12 on the equinox. Have I explained the Arctic lines and the Cancer lines and the tropic lines? Have I talked about that in this class?
I don't
Anybody?
think so.
What's that?
I don't think so.
Okay, let me talk about that for a second, because I take it for granted that people know, but they don't. Okay. All right, so you see, let me just do this. Get another one going. All right. So we have the Arctic Circle, which is this imaginary line. I'm going to have to make my pen bigger now. Is this imaginary line that runs around here. We have 2 of these on the Earth. This is the Arctic Circle, and we have the Antarctic Circle. Okay. Then we have the Tropic of Capricorn, and we have the Tropic of Cancer. Now, what do these lines mean? That means that in this region right here between the tropics, the sun does not change any. They have the same amount of sunlight all year round. Between the Arctic Circle and the Tropic of Cancer and the Antarctic Circle and the Tropic of Capricorn, we have a variance of sunlight. And on 2 days out of the year, which are our spring equinox and our fall equinox, we have exactly 12 hours of each. So on March 21st and September 21st, we have 12 hours of daylight, 12 hours of sunlight. Same thing happens down here, but just opposite. Okay, so when we're having longer days, they're having longer nights. When we have longer nights, they have longer days. So when we have winter, they have summer, and so forth and so forth and so forth. Okay, so in these regions, you have 12 and 12. Let's just say it that way. But it changes, all right? It changes. So in the summertime, we have, I don't know how many hours. Let's say on the summer solstice, we have X amount of daylight and X amount of night, and I'm not sure which is which. If somebody wants to Google that right quick and tell us, that'd be great. Somebody else Google winter solstice and see how many hours of daylight versus how many hours of darkness that we have. Okay, so above the Arctic Circle and below the Antarctic Circle, we have 0 to 24. Let's say it that way. So what that means is 6 months out of the year, they have pretty much zero sunlight, and 6 months out of the year, they have pretty much 24-hour sunlight. All right, so that's how different things work. Now, you'll find out that when you get above this line here, you have very, very little vegetation, grasses, low stuff, minimal pine trees, and you know, there's a line in which we have to draw across through here and through here. You will have deciduous trees, and I'll talk about that. We'll have deciduous trees to this area, and then at some point we lose the deciduous trees and we have conifers, cone-bearing trees in this section here. They can withstand the cold much better than these do because of the way that their leaf structures are. So as you know, a deciduous tree is a tree that sheds its leaves in the winter or in the fall and regrows them in the spring. A conifer does not. A conifer has needles, and they can get by with minimal sunlight to do their photosynthesis. I really have to think about that word to say it. So that gives you an idea of how we can decide what to use. I mean, if we're going to live in Alaska, obviously everything that we do is probably going to be made out of conifer trees. Otherwise, we're going to have to be toting trees in from mainland United States. If we're down here, if you know whatever whatever conifer trees that we might be wanting to use, again, they're going to have to be transported down here, and then we have a lot of cost involved. Now, keep in mind that conifers have a pretty much range all over the world, except for in the Arctic regions and the Antarctic regions. And the further you go north or south into these Arctic regions, the conifers get smaller and smaller and smaller and smaller and smaller. We have a species actually here in Western North Carolina. The Table Mountain pine is pretty much it's limited to our region in here. Table Mountain pine, and so you can see here how this you know, that's the region of it, and it runs the Appalachian mountain range. Well, are they usable? Not really, because they're very small trees. They can't live in warm environments. They're kind of a stumpy looking tree, but they have fairly long needles on them. So, you know, if you're in this area here and you need to use the Table Mountain pine, then, you know, that could be one way of doing it. However, they, like I say, they, you know, right there it says that, well, it says here they get 29 meters high. I've never seen one 29 meters high. Most of the ones I've seen are actually smaller than me, but that, of course, I usually see it around the gorge area here, right up through here. So that's where the gorge, the Linville Gorge is. So that'll give you kind of an idea on that. But anyway, so there is the world and how our sunlight affects us as well as our vegetation and so forth. Any questions on that so far? Anybody find out any information for us to how many hours of sunlight we have versus winter?
Yeah, I got it.
Sent you a couple of chats on that.
Oh, there are? Yeah. When I close some of this stuff, I don't see the chat, sorry. And I guess I should use that more. So, all right, so Google says in DC, 9 hours, 26 minutes on the winter solstice, and in the summer, they got 14 hours. Okay, so that's DC. Now, do we have the same amount of sunlight as DC?
We're gonna have slightly more because we're a little.
That's right, we do. We have slightly more. So here is DC right here. Am I even? Yeah, okay, DC. And then, you know, Asheville, Morganton areas down here. So we have slightly more because we are further south than DC, meaning that, you know, you get up here to the very top of Maine, they're going to have less sunlight than we do. So while I'm on that, let me jump ship here and kind of go off on a tangent. So in clean the board, why don't you erase the board before you leave the class? Okay, so in Western North Carolina, we are somewhere around 37 degrees latitude. And so when we put our solar modules, solar collectors on a house, depending on what the shape of the house is, what pitch here I'm trying to think of, then we could possibly put it directly down to the roof. So let me do that real quick. So 37 degrees is equal to a 9 and 12 pitch. So if we have a roof that is 9 and 12, then we can put our solar modules flat on the roof, providing that they're facing south. Okay. Now let's go to Maine right quick. What was the name of that town in Maine? Can't remember right offhand. Field trip. So I was looking at some land up here near one of these small towns. And I don't remember which one it was, but anyway, it was a very, maybe I'm just not far in. We'll say Grand Isle.
Caribou.
What's that?
You're right around Limestone and Caribou.
Yeah. But I was looking at some land, and I mean, it was like super way up here towards the top, and they wanted almost nothing for it.
I've been up there. There's not a lot else other than
Yeah. Yeah. Well, let's just say Caribou. So what is the lat and long of Caribou? How you spell Caribou?
Caribou.
Caribou, Maine, M-E. All right, so 46, almost 47. So let's go back over to here. All right, so we're building a house up in top of Maine here, and they are 47 degrees latitude. So at 47 degrees, you're looking at a 13 and 12. Sorry, put that in the wrong place. 13 and 12. So we're past. I'm going to draw this exaggerated. So this thing's almost standing up here. All right. So we're basically 1 inch above 12, which is 45 degrees. So keep that in mind. And we are above that by 1 inch. So you think, well, they can't have solar panels up there because they don't have enough sun. They do. You'd be surprised at the number of houses that actually have solar PV and solar thermal on their houses up here. But man, they're standing almost straight up and down. They don't need the heat in the summertime, so they will actually add 15 degrees to that so that they catch the winter sun coming in. And so let's see, 47 plus 15 is 62. That's going to be, that's going to be a 22 and 12, or excuse me, a 12 and 22 rise over run there. So that's, you know, that we're talking almost 30 degrees right there. So that they're going to be setting that thing up. So if we're looking at a triangle, it's 30, 60, 90 there, then that is going to be very, very close to 12 and 22 there. So again, those things, I had that pretty close there. So that means that they're going to be standing up, absolutely standing up to catch all the winter sun coming in there. All right, off this tangent, that's a solar class, sorry. Back over to the wood. So this tree, you know, it's been dormant for a while. It's been in hibernation during the winter months. And now all of a sudden, it's got enough sunlight to do something, and it's going, you know, it's happy. And so right there, it's going to come alive right in through March, and it's going to start growing at an, you know, at an enormous rate. All right. So you got to think, these are annular rings that you're looking at here. And I believe that's 2 right there, and I believe that's 2 right there. And they get a little smaller, and I'm going to talk about why they may get smaller or larger and so forth in here. So you can see all these going up through there. And, you know, as it's young, generally, you know, like any other young person, we start growing real fast. All right. So they're, you know, what are you doing? Feeding them kudzu or something? So that, you know, spring comes around, man, they are going absolutely wild. And, okay, so Austin says in 2019, Charlotte got 14 hours, 32 minutes of daylight for the summer solstice and 9 hours, 26 minutes for the summer solstice. You mean for the winter solstice?
Correct, yes.
Okay. So yeah, so, you know, in March, man, this thing is just growing. So there's a fine line here. At some point, it starts slowing down a little bit. And this is somewhere around June, May, June. It changes with different species. So it slows down just a little bit, and that is why you get this very dark ring in here. So you get this nice dark ring in here because it slowed down. It's you know, it's reached its maybe we got a lot of water, a lot of rain. You know, it's conditions are pristine. Now all of a sudden it's getting warm, it's getting hot, not so much water is present, which is typical, and the tree slows down a little bit. And so the sails in this portion are going to be closer together, and the sails in this portion are going to be more open. So let's, for lack of a different term, let's call these open sail, and we'll call those closed sail. All right. Don't use this. Don't. It's not a closed sail wood and an open sail wood are different. But for right now, let's just no. You know, I don't even want to confuse you with that. Let's forget that. Let's call them soft sail and hard sail, because that's really kind of what they are. Soft sail and hard sail. So the soft sail is here, which is the spring growth. The hard sail is here, which is the summer growth. So summer and spring. Well, where's the fall and winters? There is no, I mean, it is so fine, tiny. It's that big. It's not even that big. It's that big. See, it just disappeared. So, you know, it goes into hibernation, and that is generally what happens to that tree, and that's how it grows. So every year it puts these things on. So you have annular rings. Yeah, rings, yearly rings. Can't spell annular. But let's go back here and look at some of these. So again, you know, here it's in its infancy. Where's my, there it is. You know, we get, you know, it's probably young, getting older, probably hit a teenager about right there. So, you know, it's starting to slow down a little bit. And as it gets out here, of course, these get tighter. But they have a lot that goes on here. So notice let's take a look at this one here. This is a summer ring that just so happens to be a little bit wider than normal. And what you can't tell is this portion from, let me just change. Actually, I'm going to do it this way. So we have, that don't show up too well. Change colors here. So we've got, there's actually a spring growth right there. And there's a wider summer growth right here. So what happened here? And trees tell us tons of information about our environment that we live in. So we can cut down, well, not necessarily, we don't have to cut down. We can take core samples out of a tree. So we have this very small little, it's corer is what I've always called it. Tree corer tool. So there you go. And in the Forest Service, now look how expensive this dang thing is. You know, 12-inch thing, you know, cheapest one, 8 inches is almost $200 there. What the heck? So you basically, you go out to this tree and you just screw into it and like that. And then you pull it out and you can look at these annular rings. And by looking at those, it tells us what was going on in this area. So in this area, for some reason, we may have had a dry spring and a very wet summer. And so if you go out here and core your tree today, you're going to find out that the tree probably grew much more last summer than it did the summer before that. Also know that, you know, when we're looking at trees out west versus here in Western North Carolina, our trees survive and thrive much better here because of the humidity than they do out there where it's dry. Let's see, what else? Oh, speaking of out west, fire. Okay, so we can also look at, nah, I don't want that. I want the eraser. Go away. Go away. How do you, there. Let's do an example here. Let's say that on this side of the tree, we were growing good. Everything's nice and good. But for some reason, when we got over on this side, let's say that this ring kind of did this number. And this one did this number. Boy, it's bad drawing. Go the other way and see if I can do it any better. All right, let's say that they're very far apart on one side, but they're very close together on another side. What might happen there? Different things that could happen. For instance, we could have fire. We could have damage due to anything. Damage to a car hitting it, damage to a volcano, damage to an asteroid hitting. So
around here I have beaver.
okay, yeah, beaver, yeah. Just so you guys know, let me stop sharing for just a second. Now, see those? That's what a beaver does to them. That is a beaver. Those are beaver logs. They come from DuPont State Forest. So, yeah, beavers are detrimental to trees. Okay, so, you know, any number of things can affect this, but mostly, you know, we're looking at water. Water is the one thing that affects it the most. When they're really close together, it was a dry year. When they're really far apart, like that one, it was, you know, it was getting good water and we were having a good year. I wish I could clear this screen like I do that other one. Just one button and go for it. Just restart it. Okay, so we've talked about the rings, we've talked about the bark, but how does the bark become the bark and the ring become the ring? So we said that the pith was the beginning of growth on the tree. But let's pull in here and look at this little layer here, this layer right here. Cambrian layer. I still don't know if I spelled it right. Cambrian layer. So the Cambrian layer is this very thin membrane that runs around this tree here. And so it goes into mitosis, and half of the cells become bark and half of the cells become the rings. And that's where the living portion, this is super living portion of it, okay? So when you think about a tree, this is where all the living goes. Well, wait a minute, how come this is so huge and this is so thin? Well, because this breaks off and sheds just like our skin does. So dead skin cells we shed every day, and the tree does the exact same thing. So these outer cells, they die and fall off, and new cells who are nice, stronger, younger, can help protect this tree a little bit better. Now, insects love this little area right here because it has tons of protein, super protein, and nutrients and stuff in that one little layer. So when you see bugs getting to a tree, that's what they're getting at. Now they make, they may make all sorts of different webs and maybe, make their house and everything out here. But, right there is where the food source is. That's what they're going for. Now, so you get this layer here full of bugs, and then old Woody the woodpecker over here, he comes in and he wants some of them bugs. So he's gonna, it looks more like a something else than a woodpecker. But anyway, so the woodpecker is going to start coming in here. So the woodpecker takes and, he breaks all this bark up to get it out of the way so that he can get to all these nice little critters down in here and eat them. So that starts deteriorating the tree, and you will see that as well when you get into, these annular rings may just break down to nothing for a while, and it's hard for it to repair itself. I mean, it will. And, so you might see dips in the annular rings due to some of this stuff here. Again, the Cambrian layer is the layer that, these insects love. That's the food source. And then it's a woodpecker. It's not a pelican. That's what it looks like I've drawn. So the woodpeckers destroy that tree. Now, will the tree die if it has these little indentations on here? No, not really. If you really want to kill a tree, it's very simple to do. Six inches. If you remove the bark all the way around a tree 6 inches, the tree will die. Because again, this is its living layer. And by exposing it to the elements, it dries up. No nutrients flow a whole lot. Some do, but not a great deal. So when you're looking at, let's go back and let me just kill this one and go back over here to the, I don't know that I can see it very well in that. Yeah, okay. So let's open this one up. So this is that white oak I was telling you about. And the reason I pick on white oaks is because you can see these rays so well in white oak. Notice that we have the annular rings. We have the annular rings running out through here. And these almost look opposite than the other, but the thin ones are the spring growth, I promise you. I mean the summer growth. The thin ones are the summer growth. But now we got something else going on in this tree. It's not a very good color. Just use black. See all these little rays that squirt out through here? Those rays are also, I guess we could call them the vessels, the blood vessels or the nutrients vessels. Those are called, and I get quiet there because I'm trying to spell this out in my head, medullary rays. So they run, if you'll notice, they run clean through all trees have this, but the oak tree is the one that you can really see it. So let me show you what this looks like. So wait a minute, let me back up here. If I cut this tree, let's see, if I cut this tree in this direction right here, I'm not going to see them very well. But if I cut the tree, 90 degrees to these, I'm gonna cross through them some in an elongated fashion, and I want you to look how beautiful it is. And this is what most people want. You want these medullary rays because they actually glisten when you're looking at these things. They are fantastic. And when you've got, a big piece of furniture like this with all of these medullary rays, then, the furniture just bounces with it. It just looks so beautiful. And these little flecks, I guess you could say, flakes, they glisten, and you can do all sorts of things with them on that. So you can just do tons and tons of nice, beautiful stuff with these. That almost looks like sycamore rather than, not sycamore. Yeah, sycamore than oak, but it's oak. Okay, so let's take a break and let me breathe for a second, get my thoughts together, and then we're going to start talking about harvesting our wood. So we'll take about 10 minutes and we'll come right back. Okay, guys, we'll get started back. So let's talk about the softwoods and the hardwoods. So, like I said, we have different types of species of woods, and they generally fall into two categories: hardwoods and softwoods. So, hardwoods are considered deciduous trees, and softwoods are considered conifers. Now, I try to refrain from saying evergreens because not all evergreens are conifers. For instance, the southern magnolia. I'm sure everybody has seen the southern magnolia around. We have all over the place here in Western North Carolina. And the southern magnolia is an evergreen. It stays green all year round. However, it does lose its leaves. And it loses its leaves all freaking year. If you've ever had one in your yard, you're going to find out that, you know what, I'm not even, I don't think I'm sharing my screen, am I? Nobody said nothing. Danny, I'm looking at you.
I was waiting for you to pause to let you know.
Good grief. Sorry about that, guys. I keep forgetting that. Okay, so the southern magnolia is a tree that we have in Western North Carolina that is it is an evergreen. It stays green all year round, but it does lose its leaves all year round. It also has these, this is the fruit, which is the seed of the tree. It will put out this blossom, and then shortly afterwards, you'll see that we had one in our yard when I was growing up, and we used to play Army growing up, and this was our grenade. They would fall off onto the ground, and generally they fall off from here. So you got this little stem on there, and we'd take that stem and we'd break it off, and we'd hurl that thing, and you're dead, Mom. Not yes, you are. So that was our grenade. So this is a good example of an evergreen that is a deciduous tree. What about Alexa, spell rhododendron?
Rhododendron is spelled RHODODENDRON.
Rhododendron. All right, so the mountains are full of rhododendrons around in Western North Carolina, and so they can be beautiful. They have a festival, rhododendron festival, up at Rome Mountain every year, and they're just absolutely gorgeous. They are a deciduous tree, or a deciduous bush, I guess you could say. They are in the woody plant family, though they're in the bush family rather than the tree family, and that is pretty much discerned from their size, how tall they grow. One thing I want to tell you about, the deciduous will tell you if it's going to be cold or not. If you ever see a rhododendron tree, or excuse me, a rhododendron that has just drooped its leaves like this right here, you're going to be colder than crap. Okay, the further they go down, the colder it's going to get, and it doesn't wait until it gets cold. It has some method of knowing how it's going to get cold, or how cold it's going to get, and they will actually droop and protect themselves before it actually hits. So if you're ever out hiking, survival guide, keep your eye on the rhododendron. We also have mountain laurel, and it is, a lot of people think it's the same thing, but it's not. It is a different species totally, and it has smaller leaves than the rhododendron does, but they will grow right beside of each other. And so don't get confused. These will not let you know if it's going to freeze or not. They don't curl up like the other ones do. I'm trying to think of the name of the tree. I'm gonna take a stab at it. I don't believe that's it. What about just monkey tree? Yeah. All right, so this is an odd little bird here. This is called a monkey puzzle tree. That's what it is, a monkey puzzle tree, and it is the needles on it actually grow out of all of its stems, and they have a different shape of needle that you will see. So let's go to softwoods here. Actually, let me pull up one other. Some conifers lose their leaves in the fall. As a matter of fact, there is one in the rear parking lot of Bailey. And so a lot of people think these are dead. They think, oh, pine tree died, but it didn't. It actually turns brown in the fall, just like oaks and maples and so forth. And they lose all of their needles through the winter, just like that. And they look like they're dead, but they're not. In the springtime, they will come back to life and regrow all of their needles. So let's take a look at a conifer in fall. Let's see if we can see this. All right, so here you have a conifer in the fall, and you think, well, a conifer is an evergreen tree, but it loses its needles. It loses portions of its needles in the fall, just like deciduous lose everything in the fall. And you will see these get really reddish brown, and then they will fall out, and you'll have a whole ground full of these needles underneath it. And then in the springtime, how can you tell if it's growing back? Then you'll see these nice bright segments that are regrown in the springtime. There'll be a brilliant green compared to the dark green of the mature needles of the same tree. So don't think that a deciduous tree loses its leaves. Well, so does conifers. They just don't lose all of their leaves. So, when you think deciduous versus conifer or evergreen, that they get really muddy. Everything gets really, really muddy when you're thinking about those. So when we think about a hardwood, we are typically talking about a deciduous tree, a broadleaf tree. So this is what I mean by a broadleaf tree. Maples, oaks, birch, ash, all of those are part of the broadleaf deciduous tree. They put out this broadleaf, and this is nothing more than a solar panel. That's exactly what it is. So it's taking nutrients up through the ground, and it runs up into the trees and into these leaves. And as it goes into these leaves are catching sunlight and turning this into carbon monoxide or carbon dioxide. I can't remember which one. One of the two. One is good and one is bad. Well, they're both bad for us. But so the tree takes in what we give out, which is CO gas, right? And then it gives, nevertheless, it gives off oxygen, and that's what we want. So in this process of photosynthesis, then its byproduct is oxygen, and that's what keeps us alive. You remember last year before the pandemic really, really hit, or actually it just started getting going, everybody was talking about how bad 2020 was. We had the pandemic, then we had, we're going to lose all the trees in South America due to the fires down there. And then, what was it next? The riots, and then the volcano exploded, and the aliens came, and it was just, 2020 was just horrible, horrible year. So, when we have these huge fires down in South America, it does mess with our oxygen output for us, and it could be detrimental, but it's going to take a lot of trees to burn before we really have to worry about that. Trees are our lifeline. If we didn't have trees, we would not be roaming the earth today, I can promise you, because we need that oxygen in there. So the deciduous trees go into a broadleaf type scenario versus a conifer tree. Their leaves are very small, so they're very thin, and they still do the same thing. They still use sunlight to do the photosynthesis for the tree, but they do it in a different way. And when we say a conifer, conifer means that it puts out a cone. So all conifers put out a cone, and you have male cones and you have female cones. So the male cones generally are much smaller, and then the female cones are going to be much larger. And the male cones, they give off their seeds and they get trapped in the female cones. The female cones actually they get in here into these little crevices, and that is how each one of these is a seed, by the way, and that's how it's fertilized and a new tree can grow. So the male seed falls into these little scoops, I guess you could say. And in the Forest Service, we used to actually prematurely, we had a whole mess of male cones and a whole mess of female cones, and we would dry them very slowly at a low temperature until they all opened up. So when you first see these cones, you'll see them when they first grow, they're all closed up like this, but then they start maturing and they dry out, and then they open up like this. So you'll see both types here. So both of these are female cones, and so these will open up to catch the male cone in it, or the male seed into it. And that's how they pollinate and grow. So what do we use conifer trees for? Conifer trees are mostly used in construction. So we're using these for 2x4s, 2x6s, 2x8s, 2x10s, 2x12s, so forth, so forth, so forth, and so on. Our plywoods are mostly made of these types of trees because they're easily workable. They are softer, typically softer woods, meaning that their density is softer. But now, not all hardwoods are harder than softwoods. For instance, a poplar tree, or tulip poplar, as it's sometimes called. So these trees here, and there's tons, those Lombard poplars, there, tulip poplar is what we generally have around here that is native anyway. And so these, this wood here is very soft. So it generally puts out a greenish hue. Some cases, let's see if there you go. You can see how greenish this is here. So this wood is very soft, meaning that we could take, say a quarter, and we could put a dimple in this just by, running it across through here. And so this would not be good to build structural stuff out of it. However, again, like I was saying earlier, when we make this out of cabinets into drawers and stuff, this is very stable wood. It doesn't expand and contract with moisture so much. So it is also used for inside of plywood. So if we were looking at plywood, at the end grain of plywood, let's go section. Let me do another one. Plywood section, plywood oak. Let's go oak plywood section. Okay. You can see here that on the top, we have a very thin piece of oak. All right, so you can see just how thin that oak is right there. This is probably a 3/4 inch board here. Very thin. This is called a veneer, and you got another one down here. But here we have variant layers of poplar. And the reason that we use poplar in these is because it's stable. It doesn't expand and contract. So this is the type of plywood that we would use to make cabinets out of. That way it doesn't move, and we're using it in different ways, and we don't have to worry about movement. So yeah, let me explain something about that to kind of help you out. Carbon dioxide, says Austin. Thank you, sir. Let's see how I can do this. Speaker view. When I talk, does my screen come up biggest? Okay, good, because that's what I want it to do. What are these? These are straws, right? So this is a tree, and we're going to cut this tree down. And when we cut this tree down, then, well, I'm still trying, I know I'm recording this, so for some reason, all I see is Danny.
Yeah, right now we've got the box screen with everybody's names. So I'm sorry, I nodded at you when you asked if you were full screen, but you're not.
Okay. I don't know how to, I don't know. Anyway, if you go up there to view up on your right, do you have a button that says view on the right-hand side, upper right?
Yep.
Click speaker view.
Yep.
Now, does that make me full screen? Maybe.
There you go.
Full
Okay.
screen
I
online.
have to pin you. If I pin you, then yes.
Okay. All right, cool. All right. So this is wood. Okay. These are how the cells of wood grow. All right. So I have a huge bag of straws here that I've been using for years. I don't know that I would ever want to use these to drink anything out of, because I've handled them, students handled them, and they've been laying around the shop and everything else. So they've probably got all kinds of funky stuff growing inside of them. Now, so obviously we have the walls of the cells and we have the cores of the cells. So if we were trying to glue these end to end like this, it ain't going to happen. There's nothing there to hold these. All right. So if we do it this way, you know, if we tried to glue these, we're going to put some glue here and we're going to put some glue here. We have a nice wall in which we can glue these together. We're going to clamp these and they'll work real good. What do we have to deal with? All right, so again, this is the tree. The tree is growing up this way. All right, we got the roots down here and the trees up here. This is what we call the grain. Okay, so if we cut against the grain, or if we cut with the grain, all right, this is called ripping. So we're just pretty much ripping all these grains apart. Well, these straws are just like the tree. I can pull on this all I want to, and it's not going to move. I can push on this all I want to, and it's not going to do anything. However, if I have moisture or dryness, and they're gonna work. Okay, so I can manipulate these in this fashion all day long. All right, I can hit it with a hammer and I can dent these and they will stay like that. I can put a little bit of water on it and these will swell back out. If the more water that goes into these, the bigger they become. The less water that goes into these, the smaller they become. Now, when we think about how a tree grows, we think, oh, tree grows this way. But trees don't grow that way. Trees grow this way. So if they grow out, which I've showed you in the annular rings, I'm going to go out to this tree and I'm going to take my letter opener here and I'm going to put it in this tree. Okay. And then I'm going to come back in 100 years. Where is this going to be? It's not going to be up here. It's not going to grow up. The tree is going to engulf it. Lost a bark cell there. So the tree is going to grow around this, but I come back in 100 years, this nail, or this, in this case, it's a letter opener, is going to be in the same level in which I put it in 100 years ago, provided that I was the one that done it. And in the Forest Service, that is how we do a lot of the elevations and so forth when we're talking about trees. Now, we might come back in years and we've got this tree marked by GPS nowadays. Then it was, you know, we had all kinds of little crazy things that we would just. But anyway, what I'm trying to get to we would use these elevation markings to find out how much the ground has, you know, grown or descended. So all of our ground moves all the time. Our mountains here used to be as big as the Himalayas at one time. And over the years, they've eroded and they've settled. We've had movement of tectonic plates and so forth. Even Mount Everest is still growing. It is still moving due to the impact of India into the Asian continent. So it's still, you know, it's still going together, making the Himalayas even more. And that's one of the ways that we can actually do the elevations is through tree markings or through markers in trees. Okay, so here gives you an idea of a couple of different softwoods versus hardwoods: ash, maple, oak, mahogany, teak, walnut.
Want to go back to screen sharing?
Okay, thank you.
There you go.
Okay. Ash, maple, oak, mahogany, teak, and walnut. Some of these trees can be used for flooring. Okay, ash, maple, oak, teak in a boat. I don't know that I'd want it in a house, but teak is very, very good against moisture. So they use it in boat building a lot. And you see walnut used in flooring. Now, other than flooring, where would you use these? Ash, you use ash in instrument building. You use maple in furniture building, oak in furniture building. Mahogany is, so there's a fake mahogany and a real mahogany. And so the real mahogany is called mahogany. It's Philippine mahogany. And the fake stuff is called luan. Luan is a species of wood that is in the same family as the mahogany, and it has a very lot of the same characteristics, but it doesn't have that rich, dark color that mahogany does. Teak has a oil in it that prevents it from any kind of decay, and it lasts forever. But it is super hard to get a finish on. So if we were to try to put polyurethane or lacquer or anything like that on it, it probably wouldn't take. It would be kind of like trying to paint an oily piece of steel. And teak will also it will stain fabric. The oils that are in teak will also stain fabric. Walnut is a big time flooring furniture. I do a lot of my furniture. I do between maple and walnut. I just love the contrast between the two. Now, what you're seeing here is red maple. And let me disappear this screen. I want to keep that. So you have different types of maple. You have red maple, hard maple, just tons and tons and tons of different types of maples, just like anything else. And this, like this bird's eye maple, this is not a species. This is a defect in it that grows sometimes in maples. And it's a very sought after defect, obviously, because it's very beautiful. You can have ribbon defect. I bet you guys wonder how in the hell I ever got to where I am today if I can't spell. So this is a ribbon. There's a really beautiful ribbon maple board there. And again, this is considered a defect in growth. And so, but it just is absolutely beautiful. Light hits it a certain way and it will actually illuminate and look really nice. So you can just do tons and tons and tons of different nice things with maple. And it's a hardwood, meaning that the specific gravity of it is very great. What about now the hardest wood that we think of around here would be locust, right? Locust tree. Actually, let me just pull up a locust board. If you've ever done any type of woodwork with locusts, I'm going to tell you right now, you better have lots of money to put into your saw blades because it will eat your saw blades to pieces. It's super hard. It is what is considered an open grain. You've heard me talk about open and closed grains. I'm going to talk about that next. It's just super hard. You know, it's black locust and honey locust are really, really hard woods, and they actually have needles on them on their trees. I think it's the honey locusts, maybe both, I don't know, that have the needles on them. Yeah, look at that bugger. That thing will tear you up, let me tell you what. And you think a briar patch is bad. This is There is one, matter of fact, you will get to see it when we start working on the solar barn. It's right beside of it. I'm going to have to cut it down because it's just taken over and we can't get near it because it hurts, by God, when you touch this thing. So that is the honey locust. So it can mess you up, make a very bad day for you. Again, this is, let me see if I can pull up section. How about close up? Well, I'm not getting, let me just do this. Open cell wood versus closed cell. And I'm going to get wood. Where is foam come in here? I guess if I spell it correctly. Still not getting it. Wood grain, there we go. Let's see if we can get this. There we go. Okay. That's not exactly the best. There we go. That's what I was looking for. Ring porosity. So, well, no, that's two different ways of cutting it. But anyway, you get an idea of how the opened end of the open sail, rather, of wood versus a closed sail. I'm not seeing. There. So you have the open sail or, large ring porous down to the diffuse porous or closed ring. Species like birch, beech, sycamore, they are all in the closed grain, but in the harder woods such as oak, hickory, locust, they all have ring porousness like this. The ring porosity is going to be more open cell than what you see in these closed cells. Now, what makes the difference? So this is generally a harder type wood. And when we say harder, it is hard. You can knock a piss out of somebody if you hit them upside the head with this. Of course, this would hurt too, but this just doesn't give. It makes it hard to work. It's harder to run a saw through here versus through here. And let me give you an example of that. So if, let's say for instance, that I am using what's happened to my pen? It's on the floor. Well, crap. Sometimes a cat comes in here and knocks my pen off on the floor and I just had the darn thing. It's my chair. So. Sorry guys, technical difficulty real quickly. Well, maybe I won't be using my pen. Put it in a bag. Does any other pen work? No. Well, doggy, what have I done with that stupid thing? Carry it off? Pocket. All right, we'll try something different here. I don't know what I've done. I'll look for it next break. Let's go over to here. I can do it this way. Actually, can I draw with my? No, I can't. See, I can't draw with my mouse. That just makes me mad. All right, so we'll go over here to paint. So we've got our annular rings crossed through here. And this, like I said, the summer rings are generally harder than the spring growth. And when we try to cut, let's say if we're going to cut through here and at an angle somewhat, then when we're running our saw through here, then it will tend to want to follow these hard rings in here. And that's generally with an open set or a ring porosity on here. When we get to maples, sycamores, beeches, and so forth like that, then we have less tendency because the density of the summer growth and the density of the spring growth are going to be closer together, and our chisels will move through here much better. Our saws will move through here much better, more smoother is what I'm trying to say, and with less effort to try to keep it in a straight line. You'll find this out when you're using machines like a bandsaw, where you have a very thin blade on it. Those thinner blade bandsaws will try to follow the grain, and so this is what I'm talking about, a bandsaw. If you're not familiar with a bandsaw, the blades, they can come in a different variety of thicknesses, from the very thick to the super thin here. And when you're using something like this, it tends to want to follow those grain patterns in open cell than it does in closed cell type woods. So lumber harvesting. Lumber harvesting has been a kind of a pain in the butt for many moons, and you have different types of harvesting. Clear cut was the type of harvesting that was very prevalent to North America up until the beginning of until about the first couple of years of the 20th century. Now, in Asheville, we should be very proud of Asheville, because George Vanderbilt decided that he was going to start doing some sort of forestry in America, and he brought over a guy named Pinchot. I don't know how to spell that guy's name. Pinchot. Oh, because it's not spelt like it's supposed to be. Now, this is the governor of Pennsylvania, for God's sake, but that's how you spell it. Maybe it was the same guy. An American forester and politician. He served with the fourth chief as the first. Yeah, okay. So this is a guy. So it's the first of the head of the United States Forest Service. So I didn't realize he was the governor of Pennsylvania. I learned something new today. So he actually, he was brought over from by Vanderbilt he was brought over to do forestry. And George Vanderbilt was the inspirator there. So George Vanderbilt had all this, he had a lot of land, right? He built the huge Biltmore house, but I want to show you this. Think about it. Let's go map. Let's go North Carolina map, NC map. Well, let's do something else. Let's see. Map of how do you spell Pisgah? See, it's nothing like what it should. All right, so there is a map of Pisgah National Forest. Not a very good map. Let's see if there's, I want something that's going to be a little bit more distinct. There we go. Pisgah National Forest. That was the amount of land owned by George Vanderbilt. Going from all the way down here, there's Morganton, there's Lake James, all the way up to the state line, all the way down to Mars Hill, Craggy Gardens, Old Fort, Black Mountain. I don't think this is correct. I think it's actually bigger than that now. Or it was bigger than that then. And I'm not finding a good map right offhand.
One of the things they say at Biltmore when they do the tour is that from Biltmore, he owned everything that he could see.
Yeah. Oh, yeah, absolutely.
Yeah.
And he gave it to the state of North Carolina, or gave it to the not the state, but to the nation. I guess he just wanted to get out of paying taxes on it. But so you see everything. But the sad thing about it was, like you say, it was everything that he could see. Let me think about this for a second, because I know there's some good pictures. Well, poo. I don't know how to search this to find what I'm looking for. Basically, what they done is they clear cut everything. and it was just bad. And so, like you say, he would go out and he would look out across his land, and he was not seeing beautiful covered mountainous ranges. He was seeing devastation. Let's do clear cut early 1900s. This was what he was seeing. That's what he was seeing. So it was, this was what was going on. There you go. Large part of the Smokies, clear cutting. That's in West Virginia. But Asheville looked very much similar to that, because we were just trying to, we're just going to town, cutting everything down. There was no forestry in it at all. And it was very sad. So, we started doing forestry, and then, we got into better practicing. So we have, we leave the smaller things, the seed trees. We cut all of the big stuff and leave the seed trees. You do shelter wood. Now, if we have clear cutting, if we got a lot of clear cutting going on, then the first thing that's going to grow back, well, let's think about that. What is the first thing that generally grows back when you clear cut something? Anybody?
Scrub pine,
What's before that?
grasses,
Grasses. And what is taller than grasses? Say it in Western North Carolina style, briars. Okay, so you get weeds. That's right. You get weeds and briars and all this crap. You get the grasses and then the weeds, and then you get the
invasive species.
What's that?
More invasive species. You get some tree
yes.
in there.
Yeah, it does. It does wreak havoc on it, because you got all of this invasive stuff coming in and trying to take over. And so it takes, for a forest to get to hardwood status, it takes a very long time. So if we're cutting something down and just letting it go, the pine trees are going to take over, or excuse me, well, in our case, it is mostly pine trees. The pine trees are going to take over, and they're going to live for 30, 40, 50 years. Okay. So generally, pine trees lifespan is about 40 to 50 years. And then hardwoods can live much, much longer, but it takes a lot longer for them to get to the status of maturity. Let's take another break and let me see if I can find my pen, because I really need to draw stuff. I cannot teach class without drawing, and I hate that, because I'm just a visual person. So another 10 minutes, we'll be back, and hopefully I'll have my pen by then. I found it. You'll never guess where it was. How many want to guess? Anybody?
It was in your pocket.
Nope, wasn't in my pocket.
Yeah.
Good guess. In my bag with my stupid, I guess it was, I had laying it on the counter, and when I picked up all my straws and put them in this bag, I picked up my pen too. God almighty, I can't believe I've done that. See what happens when my wife is not around to keep me straight? Okay. So what I was going to draw for you. Okay, so we got a patch of land in here, and we had some trees on it, and we were going to cut them all down, and we've got deciduous trees and conifers, and we cut them down. We end up getting those grasses that's going to come back first. We've got weeds that's going to come back, and then we're going to get those, just loaded full of southern yellow pines, that are going to grow in here like crazy, you know. And what that does is that, you know, when you clear cut stuff, you will find that these trees are in a race to the sky. They're all competing so that they can get the most sun. So they have this race for the canopy, because if you get, you know, if you get a whole canopy up here, then these other trees, they grow much smaller, or much slower rather. So you've heard the term probably old growth. Old growth equals slow growth. This fast growth trees, they're not gonna be as good a lumber as this old or slow growth. Remember that our annular rings, you know, if we don't have anything in our way and we allow this tree to grow, then, you know, in 3 years, he might be that big. But we get a slow growth tree and the annular rings are going to be much closer together, and that's all we get out of 3 years. All right. So, you know, do you want this? Not really. I mean, it's a lot of wood there, but it's not very good wood. It's not very stable. Let's say it that way. Where this, if we allow this to keep going and getting bigger every year, and the annular rings don't get so huge, then this is going to be heavier dense, or more dense rather. That's the way I feel after losing that stupid pen, is dense. So it's going to be more dense, and this is going to be less dense. This is going to be strong, and this is going to be weak. Okay, so we want these annular rings closer together for a specific reason. And that comes to the next step in our talk about trees, is how they're cut. Okay, so, you know, when I say cut, I don't mean, you know, cut down. I mean how they're cut. And so, come on. So this is the way that they can be cut. And, you know, which one's going to be easier to do? It's going to be that live cut. So, you know, we just stick that log in there and we just start piling away. We just start cutting away, and, you know, we don't care where the annular rings are. We just go for it. All right. And what happens there is those annular rings play a huge part in the strength and the stability of our wood. So we've got our rings going in here. And then we're going to cut through this thing like this. And anytime you have an edge like that right there, it's called a wane edge. It's spelled a little different, wane edge. And that just means that that's where the bark was. So you might have a piece of lumber that, you know, that looks like this. So, you know, it's got a wane edge on it. Or if you're, and this is looking in section, if I were to, you know, look down on it, then, you know, that wane edge is all over the place. But now that's something that I like. All of my house, most of the window ledges and seat ledges, stair rail, all of that has, one side is cut and the other side is natural or wane. So, you know, we go and we cut all of this. We're doing our boards, and we're trying to make boards out of this stuff. And so let's get rid of this. Faster I go, the bigger this thing gets. It messes me up. Okay, so there's my board. So what happens with this board? So as it dries, you know, we've got all those cells in here, and they had moisture in them. And remember that the spring growth is more, it's less dense than the summer growth. And what happens is these, as it dries, they have a tendency to straighten. In other words, if I were to try to make this circle straight, my board is going to do this. Okay, because of this shrinking. You know, everything is trying to shrink, and it just, you know, this is going to turn into that. And I can't use this, not unless I cut it into small sections and replane it and get rid of these curves. It doesn't do me any good. So what I want to do is I want to really, let me go back over to this other picture. What I really, you know, prefer is, you know, stuff like this. The rift zone, the quarter zone, and you also have another one called Radial Zone. And so Radial Zone is, let me just go over here and draw it. It's basically cutting it like a pie. And it's very difficult. You know, you got, there's a lot of waste in a radial cut. For, you know, like a quarter zone, I don't even think that's right. I think they've got this one wrong. Anyway, the quarter zone is just like what we say. We quarter the wood, and then we start cutting smaller pieces out of it. And what that does is that tries to get the grain running 90 degrees to the face of the board. So speaking of which, let's talk about that for a second. So that you understand what I'm talking about. This is the face, and you have two of those. This is the side, and you have two of those. And this is the end, and you have two of those. The grain runs in this direction. So if, you know, if we're thinking about those straws that I was showing you a minute ago, those straws are laying in here like this. Okay. Face, side, end. All right. So you're going to hear me talk about the face a lot. So we want this grain to be 90 degrees to the face. So when I'm looking in this, I want those, I would love for those grains to be going like that. Those grains, those rings to be going in this fashion. And that way, if they're doing this, then when I go to dry my board, or it just it dries naturally, then I'm pretty much going to have an equal force on all sides because this grain is in this direction here. So these compress together, and they will compress together in this fashion too. But like the other board that we had, you know, where the grain was running in this direction, again, these have a tendency to want to straighten out. They're not going to get completely straight, but they'll try to straighten out a little bit. And I don't even know how to draw this. I'm just going to draw them straight. And that way, you know, when it's all said and done, then our board is going to be curved. This is an exaggeration. All right, so this is not the way we want. This is the way we want. And that is how we get it out of, the quarter zone, we get it out of the radial. sown. And, you know, here we're going to get some really nice boards out of the plain sown. And then we're going to get some not so good boards out of here. We could go back and, you know, cut this like that and this like this and have better boards. And then whatever we have in here, you know, it can be whatever. And you kind of give an idea of how it's going to look for each one of those. So when we go with a plain sown and the live sown as well, our rings, this is our annular ring here, and it gets stretched out. Same with over here. You know, it just gets, you know, just gets thrown out there. Those are, I'm not saying that it's a bad look, but it's not as sturdy as these two. These two are going to be more sturdy, more sought after than the others are. I need to go back to that screen and let me close this little box here and then open it up again. I'm going to close this one. There. Now I don't have that little box down here. So you can kind of see, you know, what's going on here. The annular rings are 90 degrees to the face. They're perpendicular, almost perpendicular to the face here. And that's why you get those V sections out of that. Same with this one. This rift zone, again, I don't know, it's these two, I think something's not right here, but you can see how they start off and then start getting more perpendicular to the face on here. The face is what most of the time what counts because it's the widest. Generally, your widest piece is going to be the face, and then your smaller piece is going to be the side. What can also happen here, so if we have a tree that is under a lot of force, in other words, let's say we've got an oak tree that is down in Florida, and we get those, you know, that old hurricane comes in and just absolutely plays havoc with our trees with a whole bunch of wind and blows these not necessarily down, but keeps them at this angle for an extended period of time. So what happens is, you know, we've got these annular rings that are running across through here. You know, they're running in this direction, of course, but, you know, this side of the tree is getting compressed. And this side of the tree is getting tensioned, going under tension. And what can happen is these annular rings can give way to one another and they can slide. So if I'm trying to bend this over in this fashion here, then this is being put under a lot more pressure in this direction. And what happens is these can slide. Basically, the summer growth lets go of the spring growth at the point where winter was taking place. Remember, so we had the tree and we had the summer growth, and then we had that spring growth that was inside of that. But at some point between summer and the next annular ring, we got that very thin line there of where the tree was in a dormant state, and this is a weak point because it's pretty much stopped growing. And by doing so and then jumping to a faster speed again, then it gets very weak right there, and these can slide. And what I'm trying to get at is when you get to these places here, what you'll have is a defect called feathering. So if that happens, then these will actually let go and they'll peel up. This, we're looking across the side of the board like this. These little things will just peel up. I can bet you felt it at some time or another. If you're barefooted walking through a hardwood floor and all of a sudden you ended up with, you know, a piece of wood between your toenail. That smarts, let me tell you what. So that is not cool when this happens. And it's not a good thing as well. So you get this feathering when you've got it like in this direction. But then if you see something like that in the middle, then you could have what's called as shakes. So there's two different terms for this. If it's cut in a plane saw, this will roll up and you'll get this, you know, this feathering. Or if, you know, you've got a line going through the middle or a crack going between the two rings, annular rings, then you'll have what is known as a shake. And so this is an undesirable thing too. Not a shake shouldn't be confused with, just lost my train of thought. Check, there you go. So a check is where the end of the wood dries out faster than the center of the wood. So remember that we've got all these straws in here, and because they're open on either end, then moisture can be sucked out of these at a faster rate than it's giving off here in the middle. And if this outer portion here starts shrinking, then it's going to let go, it's going to bust, and that is called a check. So let me show you some of these other defects in here. And like I say, I'm a little bit uneasy about that. Run this again, sawmill cuts. See if we get different things here. Sawmill cut. Well, they all seem to be coming up that same way. I guess the only thing I'm figuring is they're saying that this is quarter zone inside, everything outside is rift zone. And see, they're showing rift zone as radial on that one. I don't even think they know what they're doing. Flat zone, live zone. I guess it's all depending on who you talk to. Through and through cut. I love that one. But you guys get an idea of what I'm talking about here. So this even gives a totally different. There's the radial cut that I was talking about. So I used to have one of these little sawmills here. They're great, Wood Miser sawmill. I didn't personally had it. I had it at Western Piedmont Community College. We were trying to get one for AB Tech, and they turned us down. So it don't look like we'll be able to get one. Not that we would use it a whole heck of a lot, but I thought it was really cool because I teach you, some of these old tools and stuff. You're going to get your hands on some of these old tools, but it's really good to, to be able to compare the two. And it's just cool throwing a log on there and then cutting into it and seeing the different looks that you get out of it. You can get just, from one slab to another, you get really beautiful stuff here. Also, when we're doing woodwork and stuff, and we're cutting these up, and we're trying to get a pattern for a table, you see how these two, they were kind of opened up like a book. Well, that's what this is called. If we were to glue these two together here, this would be called booking. So we just cut this, open it up, and then we have the two here that would be pretty much identical to each other, and it's called a book end or a booking. Let me see if there's anything that I have missed. Grain, texture, harvesting, sustainable seasoning, usage, seasoning. We need to talk about seasoning and grades. I'm gonna go ahead and open up this too. These are some real nice. If any of these, I'll run through these and make sure that all of the links work. If anybody finds one that's not doing good, then send it to me. Let me know. This, the Lorax, that's the original Lorax Dr. Seuss movie. It's a great movie. Sit down, watch that with your kids if you haven't already. And I'll go ahead and turn on woodworking as well. You'll find that I've done some videos in sharpening tools and so forth. So look through those, and I'm going to close this test. You guys are not ready for that yet. So, so yeah, you have actually two different assignments. You got trees from your yard, talked about that, and then you have define. What I want you to do is I want you to define these words, and some of them, if you just Google some of these words, you're going to have something that is totally off the record, not even near what you should have. For instance, deal. You're going to have to search for like old English woodworking terms is what this is. So you know, make sure that you do the right search on this and come up with a good definition on it, because I want you guys to learn what these words mean, because you'll hear me talk about them again and again and again. Also, take a look at these different things. Oak family genus, or excuse me, Quercus is oak. Pinus is pine tree. So, you know, those are just some of the family names there. And that's where I talk about the you know, list of tree genuses here. Look through that. Leaf shapes, obviously, talks about different type of shapes. If you happen to go to one of the Forest Service places, some of their bookstores have some really, really nice tree identification books. I have several myself, and I use them. And there's actually, there is actually some apps that you can download that will help you if you're interested in understanding more about the trees and nature around you. Is this it? Figures. That's not what I'm wanting. Yeah, iNaturalist. So iNaturalist is a, well, how do I do this? I was going to show you the, let me just do it this way. That's what the app, go away. That's what the app looks, the app picture looks like, called iNaturalist. It's a free download, and basically you just go through there and you can take pictures of a tree or a butterfly or any tons of things. So you know, I just went out there and I took a picture of a red maple tree in my yard and put it into this, and it told me all about it. You know, so it's a, you know, it's a really nice app if you want to play with it. And there's tons of others. My son, who is, you know, one of my sons, who is the all the plant specialist guru, he says picture this is a little bit better. I don't know. Picture this costs money. iNaturalist is free. So to me, that means a lot to me. he just likes it because it gives a lot further, more in-depth stuff that even if I read it, I wouldn't even know what I was looking at. So
Find there's a little bit more user disagreement on Picture This. Some people don't agree with each other, and
oh, really?
yeah.
Well, you get all these brainiacs in one room and they're going to start fighting with each other. I don't give a flip if it's, Highness, Penis, or what. I don't care. I just tell me, is it a yellow pine? Is it a white pine? Is it so yeah, they can, it grows south of Lenore. No, it don't. It grows north of Lenore, whatever.
The other part about all those apps is they don't work when you're actually out there in the middle of the woods.
Ain't that the truth? That, if you ain't got service, but of course, the one good thing is I can take the picture, and then once I come into service, then I can upload it and it'll tell me what it was.
I've still got my little backpacking tree finder. It's
That's
thin.
cool. Yep. Any Boy Scouts or Girl Scouts out there? Of course, when my daughter was in the Girl Scouts, they were doing accounting, crochet, bacon. Hell, she didn't want to do that stuff. She ended up dropping out and joining my son's Boy Scout troop, and getting out in the woods and stuff. So she was all into the forestry stuff, that's for sure. It was kind of funny. And she didn't care if she didn't get any awards. She didn't, as she said, I don't have to wear the stupid uniform. There was something in here. Oh, grades. Imperfections and defects. We've talked about some of those. But they have, they've got kind of a little certain ones here that you need to know. And so you got shakes, and that's what I was talking about, where a shake runs with the grain. And then you've got, well, they call it splits, checks. Splits and checks to me are the same thing. Checks generally develop due to the end of the board drying fast. Let me go to see if this one's any better. Yeah. So shakes run with the grain or run with the annular ring. Checks run with the grain, but they occur at the end of the board. Bows, cups is, remember what I was telling you about that one? It was, we cut it from the very edge of the board here, and it tended to want us to do that number. The grain was wanting to straighten. Well, that's what you end up with, is a cup. Crooks, knots, splits, twists, a whole bunch of other different types of defects that you'll find out there. I love going to Lowe's, and I'm going in there to get me some wood. And, here I'm talking about 2x4s, 2x8s, 2x10s, just regular framing wood that's going to be covered. You're not going to see it. And you got Elroy over there picking up each little board and eyeballing that thing to make sure that it's as straight, you throw it back. And he'll pick up another one. He'll eyeball that thing. He'll throw it back. I don't know what, is he making a piano or what? If you're framing, I'm going to show you how to manipulate this piece of wood to work. And if it's framing, it's framing. You're going to cover it up. You're going to have boards at 16 inches or 2 foot on center, and they're not all going to have the same bow, crook, cup, whatever in them. And there are ways that you can go and manipulate this wood to get it to work for you. So, if you're searching for some nice oak or maple, eyeball the piss out of it. But if you have to get down there and look at it by closing one eye, it's good enough for framing. I promise you. The ones that you really need to look out for are the ones that you can see from a half a mile away. So keep that in mind. And when we start working with wood and stuff, we'll go over that.
Eric, my first boss, whenever a lumber delivery would happen, he'd stop us all. The guy would unload the lumber, and we'd have to cite every piece of that lumber. And if it wasn't good enough for the boss, it went back on the truck. He'd make the driver stick around until we'd done it all. And eventually that lumber company quit sending us any crooked wood.
Well, I do know, you know, some places, some sawmills, you got to be careful. Well, okay, so let's say we order a mess of lumber from Lowe's. Oh, let me show you what a Lowe's tree looks like, by the way. If you don't already know what Lowe's lumber trees look like. There you go. That's where that's the trees that Lowe's gets their lumber from, or that one. So there are qualities of lumber, and depending on who the inspector is or the grader, then you're going to have different grades of the same lumber. All right. So, and it's a thin line. It's a very thin line. If and you know, so they're trying to get rid of you know, if somebody shows up on, no, let's don't use that one. Let's use this one. If somebody shows up on, these are all hardwoods. They're not softwoods. These are all hardwoods. If you've got something that looks like this and a hardwood, you ain't going to move that thing. I promise you ain't going to move that thing. But sometimes you get it. I'm not getting any pictures of softwoods. There's softwoods. All right, so you can look at this pile here, and we're not down there with, you know, we're not down there trying to look at it down here. We're standing up, where'd that picture go? We're standing up here looking at it, and I can see two boards right now that really stand out to me. This one, you can see how it's curving in this direction, and not this one, but the one underneath it. See, it's poking its little head out here, and look right there. But it's bad. It's pretty bad. This one has a twist to it. You don't have to get down. If you have to get down there and sight them things, you need to be in a different business. I mean, you can use this wood for framing, unless you got those. You can't use that. Yeah, you can for blocking, but you know, so what I was going to say, some people, some sawmills, they will put all of their crappy lumber in the middle of a bundle, and then they'll put their nicer lumber on the outside of the bundle. They'll strap it and send it off. And, you know, so you kind of got to look for it. But again, for softwoods, if you're down there trying to eyeball it like this guy's doing, if it looks like that, which you don't have to get down and eyeball it, you know, don't get it. But if it has such slight irregularities in it that you have to eyeball it in softwood for framing, not for finishing, but for framing, then you're kind of spinning your wheels there a little bit. But I agree. I mean, there's people out there that, and that's why they got the money. They're such a pain. We had this one contractor in Morganton here that was working on the hospital when they were building it, and he went through 23 carpentry groups because of, you know, you ever heard the old story, you know, you need to pick your battles. Well, he picked all of his battles, and he was nitpicky about everything and didn't want to pay and this and that other thing. So in the end, he ended up having to really spend a lot extra money just to get somebody to come in from another state, because nobody in the state of North Carolina would work for him. So there's pluses and minuses to be that. And like I say, you just got to pick your battles. What else was I want to show you? Oh, grades. So we've got different types of graded lumber. And again, it depends on the inspector or the grader as to, you know, what's what. So all of these, so you got spruce and we've got pine. So pine is yellow pine or white pine. I think it's white pine in this case. It's not yellow pine. And let me show you how I know. Man, my fingers are thick today. See this? I didn't want to hit that. I don't want to go to Lowe's. Get away from there. See how these contrast? You have huge yellow streaks. This is southern yellow pine. And it says pine, but you don't see those yellow stripes through there. So the only thing it's telling me is white pine. White pine, see how close in general these look? So you will see spruce, pine, fir, and that's what SPF stands for. Just so you thought it stood for some sort of protection against sunlight. You will see stamps, SPF, on lumber, and that stands for spruce, pine, fir. And so these, and this is white pine, by the way, spruce, pine, fir. And so these can be very close in similarity to each other. And then others that you will see is SYP, and that is southern yellow pine. All right, so yellow pine. Okay, so that's eastern white pine versus the yellow pine. See the difference? Unfinished Douglas fir. All right, so Douglas fir, yellow pine, or excuse me, white pine, yellow pine. Let's go spruce. Spruce, nah, that's not a good spruce. That's terrible spruce. That might be spruce, but it's, I don't want to get you guys confused. Confused. Let's go with this one. Yeah, that's better. Okay, so spruce, fir, white pine. See how closely in resemblance they are? And this one is clear. There's no knots in this, which you can obviously see from these other pictures. It does have knots, and it will have knots. All right, they just took a picture of a knotted one there and one that's clear there. And then that yellow pine. See how the yellow pine really sticks out like a zebra? And this is, you know, you can see how it's, you know, this is cut towards the edge of the piece of wood versus this is cut where the grain is almost parallel to the face. So you can tell a big difference. This is super hard. All right, this wood right here, aged 50 years, will put a hurting on a piece of oak. It can be just as hard, if not harder, than oak in the end. You can't move this. Remember when I was telling you about you know, looking for that lumber that's this, if you're using southern yellow pine and you're trying to do any type, well, I don't do any type of finish work. They sell this in a finished board, but I'm not going to use, I mean, you can buy it 1x6 by 12, which means that it's 3/4 of an inch by 5.5 by 9.25 inches. And I'll talk about that later. For a finished board, I never use southern yellow pine for finished wood because of the way it moves, because of the hardness that it becomes. It cracks very easily. It's a sucky board for finish work. If you're going to do any kind of trim, spruce pine fir is the way to go. And that gives you a big difference right there on how that is. So grades. This is all 4G grades. It's not really what I wanted. Wood grade. That route, wood grade chart. So there's tons of different ways that you can grade the lumber. And this is what you'll see is select or clear, common number 1, number 2, number 3. And then when you get down here, number 4s and so forth, they'll call that, actually a number 3 is a utility board. So for select, generally select is a clear board. It doesn't have any knots in it, or the knots are no bigger than a dime. For a number 1, the knot cannot be but so big for the face of the board, and I don't remember what it is. A number 2, the knots can be a little bit bigger. A number 3 is when the knot is 1/3 or 3/4 the size of the face, and I can't remember which one that is either. So basically, it's looking at the knots. So what's the knot got to do with it? So you have live knots and you have dead knots. So, wow, that's a pretty good looking live knot there, isn't it? Versus dead knots. There. Deed knots. Wood. God. Man, okay. Here is 2 types of knots. We have a live knot and a dead knot. Now, what's the difference? The dead knot has bark that has grown around the knot. So when we're looking at this tree, as a young tree, it had a limb coming out of it. And remember that as the tree grows, it puts on more skins, I guess you could say. And this had bark on it right there. And this is how you get a dead knot. And what it is that bark, remember I told you that Cambrian layer is a kind of a flimsy layer, and it releases the bark, and that's what happens. This knot's going to fall out. This knot is, it's part of the tree. The grain is, so kind of talk about the grain on this one a little bit. That grain is basically coming around and going around that knot as it's growing, because we're looking at the annular rings right here. So the grain has switched directions all of a sudden right here. And you don't want to talk about your saw deflecting or nails deflecting. You hit a knot, and that's exactly what's going to happen. But now as it gets over here, then it transitions from doing this to doing that. And so it's going to stay there with you forever. This is a completely, totally defined line that goes around there, and there is nothing that attaches the up and down grain to the inward grain here. So that's what the difference is. So you don't want anything with a dead knot, because they'll pop out, not unless you're going for that look. So that's a dead knot, and here it gives you, there's a good side view of that. So this is the intergrown knot, where the limb has been growing out, but then here's where the tree has encased the bark on it, and then now it's turned into a dead knot right there. And I'm gonna leave that. I'm gonna save that. Try to save some of this so that I don't have to go searching through all this stuff every time. All right, I'm going to stop at this point. I want to get into seasoning a little bit, but I don't have enough time to get as deep as I want to in that. And then I want to talk about manufactured lumber as well. So I'm going to go through some more species with you on a future date. We'll hopefully, let me see, let me look at the weather right quick. Anybody? So has it been raining? I mean, it's rained constantly since we've been in class here. What's it doing in Asheville?
It's rained a
it's
good
raining
bit here.
Okay, cool. Good. I'm glad we called it in. Like I say, I don't want you guys to be out there and get miserable. I want you to learn something. Let's see what next week's supposed to look like in Asheville. Tuesday. Well, Tuesday's 41% chance of rain. Thursday's 67% rain. We'll play it by ear again. Hopefully we'll have some better weather next week. So if things go as I want, A group will meet on Tuesday at the picnic shelter for masonry, and then the Thursday group will meet on Thursday for the same thing, and then we'll go back into wood and finish up some of this stuff, and then we'll start playing with tools and doing some woodworking and stuff. Okay, any questions for me about any of this right yet?
No, sir. I think I'm good.
Nope, I'm good.
Okay, cool. You guys want off here as bad as I do, don't you?
Yes.
All righty. Okay. Have a good weekend, guys. And Tuesday's group, I'll get up with you on Monday night. If you hadn't heard from me by 8, 9 o'clock on Monday, hit me up. I just about slipped my mind the other day. So just hit me up and I'll send out a message. Have a good one, guys. Thanks.
Thank you.